Hello class, today we're going to cover section 9.3, which is about transforming quadratics. By the end of today's lesson, you will be able to identify the different transformations of a quadratic equation, both in the equations and on the graphs. A transformation is moving the graph around, and it could change the size or the position of the graph. Something you'll start hearing now in Algebra 1 and on into Geometry and Algebra 2 is talking about a parent function. This is the simplest form of any type of equation. For parabolas, it's f of x equals x squared. If we go back to what we were doing earlier in the year and look at linear equations, it would be f of x is equal to x. It's that most basic line that we could draw on the graph. The three types of transformations that we are concerned with are translations, dilations, and reflections. A translation moves the graph up or down. It could also be left or right, but we're only going to worry about the up or down component. The dilations make the graph look wider or make it look narrower. And then the reflection is what makes the graph flip over. For parabolas, the line of reflection is the x-axis, so it's going to flip over the x-axis. The reflections are what cause us to have minimums or maximums. So the parent function, just going to go ahead and demonstrate what that would look like. We've got x and y, basic values of -2, -1, 0, 1, and 2. Plugging that in, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So our basic quadratic is going to look like the following. All other quadratics are based off of this parent function. The domain of the parent function, like any quadratic, is all reals, so any number can be plugged in for x, and our range for the parent function is going to be y is greater than or equal to 0. All of the points are going up from 0. First type of transformation that we are looking at is a translation. This occurs when there is a number c added on to the parent function. So if there is a single number added on to the end, that is going to tell us up or down. If it is adding, positive, we're moving up. If it is subtracting, negative, we are moving down. So for example, I've got -4 plus x squared. So the parent function is already drawn on the graph. Again, I'm going to draw in those basic 5 points of -2, -1, 0, 1, and 2. Plugging that in, -2 squared is 4. -4 plus 4 gives me 0. -1 squared is 1. -4 plus 1 is -3. 0 squared is 0, minus 4 is -4, 1 squared is 1, plus -4 is -3, and 2 squared is 4, plus -4 is 0. So when I draw this transformation, I end up at -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. As you can see, all of the points on the graph has simply moved down 3 points from where they started. So I still have my parabola shape. Each of the points have just moved down down 4 from the parent function. That's what the -4 meant, moving down 4. The next example is dilation. This happens when there is a number being multiplied with x squared. In order to figure out if it is getting narrower or wider, we're looking at the absolute value of a. So what that means is that -2 or 2 will have the same effect on the graph because we are looking at the absolute value, and both of those have an absolute value of 2. So if that value is greater than 1, that absolute value, then the graph is going to get narrower. So those points are going to get closer together. If the absolute value is between 0 and 1, aka we have a fraction or a decimal that is between 0 and 1, we're going to be getting wider. So that graph is going to be getting pushed down. Those points are going to be farther apart. So again, on this graph, we've got our parent function drawn in, and we are going to go ahead and plug in those 5 values into our new equation. So we have negative 2 squared, which is 4. 1/2 of that is going to give me 2. Negative 1 squared is 1. 1/2 of that is 1/2, or 0.5. 0 squared is 0. Half of 0 is 0. 1 squared is 1. Half of that is 0.5. 2 squared is 4. Half of that is 2. So we come over to the graph, and we have our new points of 2, negative 2, 2, negative 1/2, 0, 1.5, and then 2, 2. So as you can see, that graph got wider than it originally was. The points have been pushed down. They are further apart. So that graph got pushed out. If it was narrower, a bigger number, the graph would have gotten narrower inside and moved in. Last thing we need to look at is reflections. That is the A value being negative. So that A value is still telling us the dilation. The negative is telling us that there is a reflection, or it is flipping over the x-axis. So for example, we've got negative x squared. What this really means is that we have negative 1 times x squared. So negative 1 times x squared. So I start by doing negative 2 squared is 4, times negative 1 is negative 4. Then I got negative 1 squared, which is 1, times negative 1 is negative 1. 0 squared is 0. 1 squared is 1, times negative 1 is negative 1. 2 squared is 4, times negative 1 is negative 4. Again, coming over to the graph, you're going to notice that is my same original graph. It is just getting flipped over or reflected over that x-axis. So this is how we either decide minimum or maximum, was with that negative. Negatives are maximums because the graph has been reflected or flipped over. So most of what you're going to be doing in the homework tonight is identifying the translations based on equations. So you're actually not going to have to graph them in the homework. That was just a visual to show you what they looked like. What you do need to do is go through and check all of them. So the first thing for g of x, I'm going to check, is there a translation? There is, because I've got the addition of 6. So I'm going to say it's going up 6. Then I need to check for a dilation. There is no number in front of x squared. So I'm going to say no dilation. And then we're going to check, and we have no reflection either because it is not negative. So you want to go through and double check all 3 of those elements. Coming over to h of x, that has something I need to simplify first. So notice that x is negative. I can simplify that by squaring it. So negative x squared actually turns into positive x. So I've got h of x is equal to 2x squared minus 9. That one's simplified. That negative's in the parentheses, so the squared cancels it out. So now we need to go through and look at our transformations again. This one is down 9 because of the negative 9. There is a dilation because of that 2. Since the absolute value of 2 is 2, that is bigger than 1, we are getting narrower. And there is no reflection because the negative was in parentheses, so it got canceled out by the squared. Go ahead and try j of x and k of x on your own. J of x is a reflection, wider and down 3. K of x has no reflection, narrower, and up 13. If you notice, the order that I have here is different from the order I had on this first slide. It does not matter what order you list the transformations as long as you have all 3 elements. Last thing that you'll be asked to do is pick out which equation is accurate for a graph. My suggestion here is to start with that translation value. So we're seeing, instead of starting at 0, we are starting at positive 5. That immediately eliminates the first two answers because both of those have a transformation of negative 5. The next key thing to look at is the reflection. That's the next visible element. Whether we are going up like a normal parabola or down like a reflected one, in this case we are going down, so there is a reflection. The only one left with a reflection is C. D does not work because it is not a reflection. Go ahead and determine this transformation on your own. The correct answer here is C. We started at up 1, and it is a reflection, so it is going down. If you have questions about this or anything else from the lesson, please let me know when you get to class.